Did you know that your e-mobility not only contributes to a clean planet, but can also light up areas where electricity is not available? Let's take a look at how two stories that seem completely irrelevant lead to the e-mobility ecosystem. In Cambodia, electricity was available to 75% of the total households, or 2.68 million households, as of the end of 2019. However, 25% of the country is still an off-grid area with no electricity. In off-grid areas, electricity can be used only by building a standalone energy system. A standalone energy system has the advantage of being able to generate electricity at a fraction of the cost of building a power plant. However, creating a standalone energy system is not easy. As the use of e-mobility became more common, greenhouse gases generated from vehicles decreased. However, the discharge of waste batteries has accordingly increased. Waste batteries pose a risk of fire and explosion when exposed to the outside and contain toxic substances. Therefore, if we just throw away the waste batteries, it would not be reasonable to say that we have invented e-mobility for a clean planet. What can we do with waste batteries discharged from e-mobility? At this point, we come up with a solution, which is EIP, an eco-industrial park that recycles industrial waste to create new raw materials or energy. How about applying the ecosystem for resource circulation to businesses related to e-mobility? Through the e-mobility ecosystem, batteries that have reached the end of its lifespan are circulated to a remanufacturing plant or an urban mining plant after performance evaluation. Waste batteries become a household ESS through remanufacturing or are used again as raw material. A single battery remanufactured can store enough power to be used by a Cambodian household for 2 to 3 days. It also can store the electricity produced by solar modules and later send it out when needed. Thus, the waste battery of e-mobility becomes a resource that illuminates the off-grid market, solving the problem of discharged waste batteries. Through this, we can solve both the power supply problem in Cambodia and the waste battery discharge problem in e-mobility. Waste batteries that cannot be used as ESS or that have already been reused and can no longer function as batteries are sent to urban mining plants. First, the waste batteries are discharged and disassembled. The metals are sorted to recover cobalt, manganese, nickel, and lithium. The minerals obtained here are used to manufacture new batteries at the manufacturing plant. If we build an e-mobility ecosystem in which resources are circulated through active remanufacturing and urban mining projects, we can envision various business models applicable to off-grid areas. The Earth we live in is an ecosystem made up of a cycle of resources and energy. For sustainable development, we have to think of the world as a huge ecological industrial park that is organically connected all throughout. We will create a safer and more reliable carbon-neutral system with the e-mobility ecosystem for a healthy and clean planet.